What I want to do before we start the new stuff is, and if you want to jot it down, that's up to you. But every day I want to start class going through the common degrees that we need to change into radians quickly without converting pi over 180. All right, I want to make sure we're on top of these 7 because they're going to be used a lot, and you'll see that today. All right, anybody remember 30 in radians? Pi over 6, yep. 45, pi over 4. And if you don't know them now, it's fine. We just got to pi over 3 for 60. Oh, look at this, huh? Remember 90, 180, 270, 360, we call quadrantal angles. 80 is pi. 270? Not 3 pi. 3 pi over 2. And then 360, 2 pi. Okay, so if we have to go back and look, keep going back, that's fine, no big deal. But these are the most common ones we're going to use. Basically, honestly, the only ones we're going to use throughout the unit. The rest of the unit, anyway. All right. Just give a few more to copy those down for people who want to. Okay. So let's use these now, 30, 45, and 60 in particular today. Short day, so hopefully enough time that I can come around and help you on the assignment. Okay, so what I want to go back to first is those special right triangles we talked about last week, the 45, 45, 90, and the 30, 60, 90. What's labeled as 1 here in the 45, 45, 90? That's called the hypotenuse, everyone agrees? And do you guys remember anything about the sides across from the 45s? Not the rules or anything, but do you remember what I should know about them? The 2 sides across from the 45-degree angles and a 45, 45. What's that? Legs, yep. And what should I know about them still? They're the same value, right? They should be the same. And I'm not going to have you guys rehash and look back and figure out the rules and figure out what these side lengths should be. But when this hypotenuse is 1, the sides opposite the 45s are going to be radical 2 over 2. And that'll come into play when we get to this big circle here in a minute. All right, both sides are the same, radical 2 over 2. Now come over to my 30, 60, 90. Everyone also notices the hypotenuse is still 1. Real quickly, anybody remember the relationship between the side opposite 30 and the hypotenuse? Anybody remember that at the top of their head from last week? If not, I don't care. It's fine. I double that side, right? So to go backwards there, I take 1/2. So across from the 30, yes, would be 1/2. And across from the 60 is going to be, if you remember, multiply this by the square root of 3, radical 3 over 2. So across from the 30 is going to be 1/2, across from the 60, radical 3 over 2. So what's the big deal? Why is this 1? Why do I want that to be 1? I want to introduce you to where we're going to be here for the next couple of days into next week. I want to introduce you to the unit circle. The unit circle. Why is it called unit circle? Everyone sees, and I'm going to stay basic here. Everyone sees the circle, right? Here's the center. What are all these called here? What are all these here? I go from the center to a point on the circle. Everyone agrees. Every time I draw a black line in here, that's a radius. Yeah, right? Okay. It's called the unit circle because all these radii have a length of 1 unit. That's where the name comes from, unit circle, 1 unit. So this right here, and you don't need to write it down, but that's 1 unit, that radius. This radius, 1 unit, 1 unit, 1 unit. And as you guys can see, as I go all the way around, you guys are used to the 0, 90, 180, and 270 we put the graph angles. Now making them even smaller. You see how I put the 30, 45? I go by basically 15 degrees every time here. So what I'm going to show you right now is what's this coordinate on the unit circle? What's the x and the y coordinate? And you're going to help me find it. Okay, you're going to help me find what's the x and what's the y coordinate at 30 degrees on the unit circle. Ready? How long is this side again?
1.
It's called the unit circle, so that's 1. I'm going to make a right triangle out of this. And I'm only going to do this once. What degree measure am I at right now on the unit circle? I want to find the point at 30 degrees. So ready? Here's 30 degrees right in there. There's 30. Look familiar? What type of triangle am I building here? Yeah, 30, 60, 90. Isn't this the same one you have above on your sheet? Okay. So what did you have across from the 30 then? What side length is across from the 30? I erased mine already, but okay. So ready? This side here is going to be 1/2. And what's across from the 60? Square root 3 over 2. Everyone can see I'm getting that from the triangle above. 1/2 was across from the 30. 3 radical 3 over 2 is across from the 60. All right. That's going to help you give me your point now. What's the x coordinate at the point on 30 degrees? Look on the x-axis. What did you guys write? Radical 3 over 2 is the x coordinate. And then go up. What was the y coordinate then? 1/2. So at 30 degrees on the unit circle, this point right here is radical 3 over 2 comma 1/2. And we got those points from your 30, 60, 90 triangle. Okay, you guys don't write anymore because I'm going to erase and I don't want your paper to get messy. So let's go to 45. Can we find the coordinates at 45 now? I'll draw the triangle on my screen up here. You guys just leave it on yours. Okay? So now I have 45 degrees. What type of triangle do I have now? 45, 45, 90. Ready? What's across from the 45s? Both of them, right? Radical 2 over 2. Radical 2 over 2. So guess what my coordinate is at 45 degrees on the unit circle? The x and the y are radical 2 over 2 and there we go. And you guys, hopefully you see where I'm coming from. I just didn't want to throw these at you and say memorize it. I want you to see where they're coming from. Yes, Jeremy.
Where do you get the numbers from Washington over to?
It's a 45, 45, 90 triangle, and I already know this is 1. The hypotenuse is 1 because I'm on the unit circle. It's the same triangle we just did at the beginning of class. See what I'm saying? And then we said what? This was radical 2 over 2, radical 2 over 2, right? It's the same triangle, Jeremy, right? Now the bottom part is my x-axis, right? Top part's my y-axis. So that's why it's radical 2 over 2 for x, radical 2 over 2 for y. Good? All right. And I'm going to do one more with you, which is at 60. Watch me build this triangle now. Here's 60. So now this angle's 60. What type of triangle do I have now? 30, 60, 90 again. Here's 1. Ready? What's across from the 30?
1/2.
I erased mine. And what's across from the 60?
Radical 3 over 2.
Everyone with me so far? We okay? All right, so what's the coordinate at 60 now? What's the x coordinate on the x-axis?
1/2.
Now it's 1/2. And how about the y coordinate?
Radical 3 over 2.
And I'm going to stop doing the triangles, and you'll see why, even though we need to figure out all these coordinates here. What's that?
The one having radical 3 over 2 flip with.
Correct, because look, now that's 60 instead of 30, right? 45, it's the same. Radical 2 over 2, radical 2 over 2. You just make sure you got to keep the 30 and the 60 straight. Okay, any questions here? Because now I'm going to try to perform some magic. Let's go to 90 degrees. 90. I'm not going to make a triangle out of this. What's the coordinate at 90? All right, I want you guys to think about a graph right now, XY graph. How long are each of these radii again? So this is going up 1 unit, remember. Think about it. What would be this point on an XY? Don't yell anything out. What would be that point on an XY axis? Look, right here. This point here, when you know this distance is 1, what would be this coordinate on the x-axis, or on the y-axis, excuse me? That's going up 1. What's that coordinate on the y-axis? What would you name it?
1, 0.
1, no, it wouldn't be 1, 0.
0, 1.
It would be 0, 1. 0 on the x, go up on the y, 1 on the y. 0, 1. Okay, we have to go all the way around now. I want to know what it is for 120, 135, 150, but I'm going to make this easy on you. Here you go. What would be the coordinate at 120? Oh boy, oh boy. You know what you have to do? Can you find the reference angle at 120?
Yeah.
I hope so. I hope so. At this point in the unit, you can find a reference angle. Reference angle for 120. Reference angle for 120 would be 60. Ready? What's the coordinate at 60?
1/2 over radical 3 over 2.
1/2, comma, radical 3 over 2. Oh, one small catch.
Negative.
One small catch. Stop. Yep, one small catch. What quadrant? We're in the second quadrant, right? Well, guys, what do you know about your x coordinates in the second quadrant? Oh, so what's got to be negative for me? The 1/2. Perfect. The coordinate is equal to whatever the reference angle is, except I got to make sure I get the signs correct. Everyone understand why it's a negative x? These are all negative on this side of the x-axis. All right, 135. What is the reference angle for 135? 45. So now my coordinate at 135 will be the same as 45. Radical 2 over 2, radical 2 over 2. But again, I'm in the second quadrant. What do you know about the x's in the second quadrant? They're negative. The y's are positive, so I don't touch it. 150 reference angle for 150. 30. So I look at 30 and it's radical 3 over 2, 1/2. Same thing, I'm in quad 2, so negative radical 3 over 2, 1/2. All right, how about 180? 180 degrees. Remember, how long's the radii? 1 unit there. So what would be that point on the graph then? If this is 1 out here, or negative 1. What's going to be this point right here? No reference angle because it's on the line. It's 0s and 1s. What's up, Connor?
-1, 0.
Perfect. -1, 0 at 180. All right. Do you think you could find the rest maybe? Find the reference angle and then say, are the which x, y, both, are they negative, positive? All right. If you want to talk to people in your group about it, go right ahead. I'm going to give you a good 3-4 minutes here to try to find the rest of the angles we haven't labeled in the third and fourth quadrant. Find the reference angle. Write what its coordinates are, and then say, all right, should one of these or both of these be negative? We'll get back together in about 3-4 minutes. Find the reference angle. Oh, good. Okay, 210. What's the reference angle for 210?
Negative radical 3 over 2.
Well, reference angle, not even going to the coordinates yet. Reference angle for 210.
30.
30 degrees. So I remember, or start to remember, 30 is radical 3 over 2, comma 1/2. But what do you know about the x and the y's in the third quadrant? Both negative, yeah. So x and y have to be negative here. So that's the point right there. 225 is going to be 45-degree reference angle, negative radical 2 over 2, negative radical 2 over 2. And then finally 240, 60 degrees, right? 60. So negative 1/2, negative radical 3 over 2. What'd you guys get for 270?
0,
Zero,
negative
negative
1.
0, negative 1. And then here we go. Let's see, I haven't used green yet. 300, reference angle.
1/2.
It's reference angle,
6.
60. So it would be 1/2 radical 3 over 2, but
Negative.
which one's negative, x or y in the fourth quadrant?
Y.
Y, negative. All right, let's finish this up. Radical 2 over 2, comma, negative radical 2 over 2. And then at 330, radical 3 over 2, comma, negative 1/2. And maybe I should have started here, but it's fine. 0 degrees or 360?
1,
1, 0. Okay. That'll be there for you to use if you need. Okay. But hopefully you'll start picking this up quick, especially what I just tried to describe to you guys before I started here. Really, I think those are the only two you need to remember. 45, they're both the same. Right? You just got to remember the correct order for 30 and 60. Questions, comments? Okay, now I'm going to turn this over to you guys by calling on you. 3 things I want here. 3 things on part A, B, and C. Name me the quadrant I'm in. Draw me the diagram of the graph. And then what point would it be on the unit circle? What's the x and the y coordinate on the unit circle for it? So negative 120. You tell me however you want to start. You may not like negative angles, so then tell me where to go. Okay, tell me where you want to go here. So negative 120. I need to know quadrant. We're going to draw the diagram together. And then tell me where I am on the unit circle. 18. We have an 18 here today? No 18. All right, no problem. Got to find somebody. 1. Ready, Elizabeth? Okay, what do you want to do? Do you want to do anything to negative 120 before I start?
Subtract it from 180.
Subtract it from 180? Why is that? We usually, what do we do with the negative angle here?
Add 360.
Go ahead, add 360 so we can make it positive. So this will be what angle here?
240.
240. All right. Last question for you. What quadrant am I in then?
You're in the third quadrant.
Okay. So I'm in quad 3. Okay. Next step. Draw me the angle. Graph the angle for me. Graph the angle. Elizabeth already said we're in quad 3. Let's see, 240, that's closer to 270. But remember, I didn't ask you to graph 240, did I? I asked you to graph negative 120. So talk to me about my arrow here. 8? Do we have an 8? Connor? What about my arrow here?
You put it this clockwise.
Yep, and then clockwise because it's negative. So that's what it should look like right there. Now, I know it's easy just to flip back and forth, look at 240 and jot it down. I want to try to get you out of that habit now. Okay, because pop quiz on Tuesday, you won't have that big circle diagram on you. So I got a question for you then to help you guys along. 20 in the house, 20? Okay, Sarah, what's the reference angle for 240?
It's gonna be 60.
Okay, so I know the reference angle is 60 degrees. Do you remember the coordinate on the unit circle for 60? 1/2. I'm just going to write 1/2 radical 3 over 2. Everyone agrees that's the coordinate for 60. Now I got to think I'm in the third quadrant though. So what coordinate or coordinates have to be negative? In the third quadrant. Yeah, your x's are negative. So are the y's, right? So both have to be negative. So that's my train of thought for you guys. Find the reference angle, 60, write down their coordinates, and then figure out, all right, based on the quadrant, which one should be positive and negative. Questions there? All right, next up, pi over 3. That's a quick one for us. Hopefully. 16? No 16? All right, let's go. Hear from somebody. 6? Ryan? Pi over 3. That should be one of our quick ones. Or that's what? 60 degrees? Good. 60? What quadrant?
First.
Good. Graphing it. It's in the first quadrant. Closer to 90. Tell me something about my arrow now. Tell me something about the arrow. 22, Jeremy?
It's closer to the 90.
I know, but what I'm talking, no, I didn't mean my terminal side. I meant my rotational arrow.
You, if it's positive, so you turn counterclockwise.
Yep. There's 60. And now what's that point? 60 degrees on the unit circle. I don't need to find a reference angle. So what's 60 degrees on the unit circle? Where am I on the unit circle? 18? We didn't have one. That's fine. Let's keep going. 11? Do I have an 11? No. All right. We'll get somebody. 10? No. No. We'll get somebody. 21? No. All right. Thanks, Sarah. 1. Elizabeth, back to you. What's the coordinate?
1/2 and square root of 3 over 2.
Does each of them have to be negative at all? Nope. I'm in quad 1. Both positive. All right. Good. And one more before I let you go and try the assignment. 3 pi over 2. That is a common one. Or pi over 2 is a common one. Multiply it by 3. So I don't have to convert off the formula sheet. I have a 15 in the house. 15. Hi, Mike. 3 pi over 2. It's a quick one, or pi over 2 is 2. What do you got?
It goes to 90 times 3, so 270.
Yep, so Mike did pi over 2 was 90 times 3. 90. I don't know what's going on there. Let's try it again. So he said pi over 2 was 90 times 3. Yep, 270. What? Am I in a quadrant, Mike?
No, you're on the line.
Good. That's no quadrant right here. No quadrant. It's a quadrantal angle, but I can still graph it. That's not an excuse not to graph. Ready? Initial side. We know where 270 is. Right here. I could still graph it. What about my rotational arrow now? We have a 9. There we go. Frank, rotational arrow. Positive 270. Start on the initial side. Counterclockwise. 270. And then what would be that point? Remember, on the unit circle, this is a length of 1. So what's that point right there? What is that point if that's a length of 1? 20? Sarah, what's that point if that's a length of 1 right there on the y-axis? 0, negative 1. Yep. Okay. Call me over if you need anything. It's the same exact thing we did here. Find the quadrant, draw the angle. Where are you on the unit circle? You could probably get almost all of this done. Call me over if you need some assistance. Find the reference angle. Then say, is it 30, 60, or 45? I promise you, will not be a different reference angle. It'll be one of those 3.